Decide whether the relation defined by the graph to the right here defines a function, and then give the domain and range. So does the graph relation define a function? So let's take a look at this graph. So here is our graph. You can see that there's an arrow extends down this way and then extends up that way, and you can see that it goes up and then it comes back down and then it goes back up. Okay, so now what we want to do is we want to see if this is going to pass the vertical line test. Okay, so does this pass the vertical line test? So that means if I put a line through this graph, okay, it's only going to pass through this graph once. Okay, I can do it again in another point in this graph. It's only going to pass through the graph once. So I can do as many as I would like to see that this is a vertical line test. It allows me to see that it only passes through the graph at one point. So therefore, this is a function because it passes the vertical line test. So let's go ahead and then write that here. So we can see here that to determine whether the relation represented by the given graph is a function, we're using the vertical line test. If each vertical line intersects a graph no more than once, then this relation is a function. This graph satisfies the vertical line test because every vertical line intersects the graph of the relation no more than once. Now, this graph is the graph of the function because the graph passes the vertical line test. Therefore, the relation represented by the given graph is a function. So let's go ahead and say yes, check, and there is our result. Now we need to determine what is the domain of the graphed relation. So the first thing that we need to remember is, what is the domain? Well, the domain is all the x values that correspond to this particular graph. Okay, so if we take a look at the x-axis, okay, this is our x-axis. Okay, and you can see the x-axis goes from negative infinity to positive infinity. Okay, and the reason why it's going to go that way is because the arrows means it keeps extending. Same over here. So therefore, we're going to say that the domain of this function is going to go from parentheses negative infinity to positive infinity. Now again, let's go ahead and explain this more further. The domain is the set of all the x values of the points that's on the graph. Now note that the arrowheads indicate that the graph extends indefinitely to the left and to the right, therefore giving us that domain. So let's go ahead and put in our answer. So we have parentheses negative infinity, comma, positive infinity with parentheses. Check our answer, and then there is our result. Now we want to find out what is the range of the graph relation. So let's take a look at the graph. Now remember that the range represents all the y values. Okay, so when we take a look at this graph, this is our y-axis that represents all the y values. Okay, and you can see here that it goes from negative infinity down up here to positive infinity. And that means that every point on the y-axis is going to correspond to something on this graph. And therefore, we're going to say that the range of this function also goes from negative infinity to positive infinity. And again, a more detailed explanation here. The range is a set of all the y values of the points on the graph. And then the arrowheads indicate that the graph also extends indefinitely up and down. And so therefore, let's put in our answer. We have parentheses negative infinity, comma, positive infinity with the parenthesis. Check our answer, and there is our result.